The topic of this video is machine learning, more specifically deep learning. Machine learning can be divided into two main topics, unsupervised learning and supervised learning. With unsupervised learning, you give the computer a bunch of data without telling it what the data means. The computer will then group similar data according to the specified features. Examples of features may be color intensity and position of pixels in a picture, or height and weight of animals. One algorithm for unsupervised learning is k-means. You supply the number of classes you want the computer to divide the data points into, and the computer will create centroids such that the data points belong to the centroid closest to it. After the centroids have been placed such that the sum of the distances to every point is minimized, groups are drawn up, and new data entering the classifier will be placed accordingly. In supervised learning, you consider a system as a black box with inputs and outputs. This black box can be seen as a function mapping a set of features to some output value or label. For example, using features such as fluffiness and a tail recognizing a cat. The ultimate goal in supervised learning is to find this function, or more specifically approximating it by learning by example. Depending on the output, we have two types of supervised learning, classification and regression. If the output is continuous, for example a temperature, supervised learning is the classical problem of regression or curve fitting. This can be used to predict an output value given a set of inputs. If the output is discrete, we have classification. That is, given a set of input features, recognize the correct objects. The way this function is found is through training. A fairly large amount of labeled data has to be generated to accomplish this. Most of the data is used for training, but some of the data is saved for testing afterwards. It is important that this test data is different from the training data. In training, the goal is to approximate the function such that the error between the label and the function value is minimized. In the rest of this video, we are going to stick with the classification problem. There are several methods to do supervised learning. One of them is the artificial neural network. Neural networks is an approach to supervised learning that to some degree mimics the way the brain works. In the brain, special cells called neurons sit next to each other and communicate their impression of whatever signal they're receiving. Artificial neural networks have nodes that act like neurons. They receive inputs which they interpret and pass on. If certain features are present, some neurons of the next layer are activated. This is then considered to be the input of the subsequent layers. The last layer decides the confidence that the input belongs to a certain class. Deep neural networks utilize many of these layers in succession to train highly complex classifier. Each layer of the net provides a more abstract interpretation of the input data. This technique allows deep neural networks to recognize faces in an image, make decisions in a game of Go, or recognize speech in an audio file. This is a simple example of how a deep neural network may work. This neural network consists of several layers of nodes working together in order to recognize cats in pictures. The lower layer of nodes starts by looking at the picture and makes some calculations on what it sees. At this level, the nodes have no idea of what is in the picture, but the information they provide is useful for the upper layers. The following layers use the given information in order to provide more detailed information about the picture. The higher the level, the more abstract information is provided. The first layer may see color information about each pixel. The next layer uses the pixel information to detect texture and edges. Each subsequent layer uses this information to detect more abstract features like paws and whiskers. The upper layers connect the paws and whiskers to the cat's body. At the very top is a node that makes the final call about the picture identification. This node uses all the information provided and determines how likely it is that the object in the picture is indeed a cat.